mass energy and nuclear binding energy. Okay. Yes. We have, I think we have radioactivity before that. No. We have mass energy and nuclear binding energy. What do you mean by mass energy? It's 13.3. See, in 1905, in 1905, in 1905, I write here, in 1905, Einstein, in his special theory of relativity, suggested that Einstein, in his special theory of relativity, suggested that mass is the form of energy. He predicted mass and energy are equivalent. See, through his theory of special relativity, Einstein demonstrated why mass must be considered in different types of energy. Before this development, a special relativity, it was believed that the conservation of mass and energy in a reaction occurred independently of one another. But as Einstein demonstrated, mass is also a type of energy. It can be transformed from mass to other type of energy, such as kinetic energy and vice versa. The well-known mass-energy equivalency connection was provided by Einstein. In this case, the energy equivalent of mass is related by equation above, where c is in the vacuum light velocity, which is about 3 into 10 raised to 8 meter per second. In the study of nuclear reaction involving nucleons, nuclei, electron, and other more recently found particle, experimental validation of Einstein mass-energy relation has been accomplished. What is this? This is mass. And what is this? What is this? This is light. See, from this theory, now Einstein explained that if energy is releasing, mass will also release. Like, see, if we have proton and neutron, yes, we will going to discuss about the nuclear, about the defect. If we have, let us consider that if we have 1 kg of proton, just a hypothetical situation, 1 kg of proton and 1 kg of neutron, if we combine together that both of them, then what will happen? We must have got the nucleons of around 2 kg, but it will not be 2 kg, it will be 1.8 kg. Where the 200 gram went, that 200 gram went with in the form of energy. Yes, in the form of energy. Okay. Yes. Now we have nuclear binding energy. Yes, here we have the defect concept, mass defect concept. Mass defect concept. See, what is the meaning of mass defect concept? The defect of nucleons is less than the sum of mass. Sorry, the if the mass of mass defect. I'll give you the definition of it. I'll give you the definition of it. The mass of nucleus is less than sum of mass of all nucleons, making it the sorry the mass of nucleus is less than sum of mass of all nucleons. Sum of mass of all nucleons, making it. This phenomena is known as mass defect. Okay, let us consider that we have a group of proton and neutron. Just a random consideration. Okay, just don't go on the size of these balls. We have proton, neutron, proton. We have neutron, proton, neutron. We have proton, neutron, proton. Okay, these are known as nucleons. If I combine this thing, if I combine this thing, I'll get nucleus. I'll get nucleus. Okay, so in nucleus, if I check that this is nucleus, I will get mass of nucleons will be greater than mass of nucleus. The remaining mass is disappeared in the form of energy, and that is known as mass defect. Okay, that is known as mass defect. What else we have for mass defect? Let's see each thing one by one. Yes. For mass defect, the mass that is disappeared is termed as mass defect. Okay, in short, the mass which is disappeared is known as mass defect. Okay, the mass which is disappeared is known as mass defect. So if we have this thing, if we have X element from A to Z, here number of proton will be Z and number of neutron will be A minus Z, right? So here delta M will be mass of nucleons minus mass of nucleus. What is the meaning of mass of nucleons? Mass of nucleons means mass of proton and mass of neutron. What is the meaning of mass of nucleus? Mass of nucleus means mz. What will be the energy released? The energy released will be E is equal to mc square. So that will be equal to, in place of m, that is a mass defect, so we can write the value of mass defect and c square. C square means 3 into 10 raised to 8 square. That 3 into 10 raised to 8 square, that energy will be what? That energy will be equal to 331.75 mega electrovolt. And in case of delta m, you will write mp plus mn minus mz. The mass which disappeared is known as mass defect. Delta m can be calculated by mass of nucleons minus mass of nucleus. What is nucleon? Sum of proton and neutron. So that what if the energy release? That energy release will be E is equal to delta mc square. That square mc square. C is 3 into 10 raised to 8. So here you can write it as 9.931.75 mega electrovolt. Okay. Yes. Now what? Now this was the mass defect concept. Okay. Yes. Here we can see few more things, like I'm just zooming this part. Okay, I am just zooming this part so that I can explain this thing. Okay. See, what is the meaning of binding energy? The energy which required to break the nucleus is called nuclear binding energy. The energy required to break is known as nuclear binding energy. Now, if you check this thing, what you will get? You will get here. You will get must be here. So what? Yes. Now, in this case, binding energy per nucleus. This will be stable one. This will be stable. Before Fe, this part will be stable. The point which I am marking, this region is a stable region. Okay. Now, second, from Fe till uranium, till before uranium, this will be the most stable nucleus. This is bit stable, unstable, yeah. But from Fe till uranium, it will be most stable nucleus. Most stable nucleus. After that, okay, this will be unstable. Okay, na? Yes, this is stable, most stable, this will be unstable. And what do you mean by binding energy? The energy required to break the nucleus is called binding energy. Yes, let's see few questions based on this. Tell me which is the correct one. The mass energy relation proposed by Einstein is, options are, the options are this, or this. This one. E is equal to mc square, not mc stand, mc square.